Hello everybody, it's Brian from quantlabs.net here. This video I'm going to be showing you what most likely will become my high frequency trading platform GUI, or client interface, or whatever you want to call it. And I'll show you what I'm basing it off of and how I'm approaching it. Being here in Canada for automated trading, the only real worthy broker to work with is Interactive Brokers. So right in front of your screen, or in this video, you're looking at the IB API software. Now you can download it for Windows, Mac, Linux, whatever version you want. I am going with the Windows. Just before we proceed, there's the Windows versus the Linux debate, the Java versus the C++ debate, the MATLAB, and R. I'm pretty well settled on where I'm going with this as of this day forward. I'm just a lot more productive in the technologies and tools that I'm about to show you and what I'm using. All the other technologies that you don't see here outside of MATLAB, I played with enough and have realized that they're going to hit some kind of limitations, regardless of open source or not. So let's proceed. So what we're going to do is obviously download the Windows version. In there you will receive basically a variety of different packages. There's the Java. There's the ones that I'm going to be focusing on, the test socket client, which is a C++ one for the TWS. Also, there's the shared end socket client. So let me just show you what I'm referring to. In here, there's a document from Interactive Brokers that you could search for, getting started with the TWS C++ API guide. In there, it will list out what you need and how to get things building for Visual Studio. Do note that there is a POSIX version because of I might probably proceed with that version, but this one I'm working with in this video is the one for specifically for Visual C++, using a lot of the .NET calls. I'll be confirming all that probably in another video, but let's get started. I don't think it'll make much difference if you use either project. Let me just pull up what I'm referring to here. In the JTS, I'm referring to, there's a test socket client, and then there is the this one here, the test ActiveX client for VC. So I'm going to probably try to play with this one. This one right here, test ActiveX client VC, is the one that obviously works with ActiveX. I haven't seen any documentation for this one, but I'll try playing with it within my Visual Studio. The difference between these two projects is, from my understanding, is that the test ActiveX client uses a lot of .NET hooks and a lot of the .NET API, which I'm trying to avoid actually. And the reason for that is, in case I am not happy with .NET for whatever reason, I can easily port, hopefully, and easily port over the code into another environment, another operating system like Linux, let's say. So that's what I'm hoping to do. But for now, I'm just going to try out this ActiveX client, and let's proceed. All right. So a few things I should mention here before we get to that. We have the TWS running in the background. Do note about the configuration to allow the TWS to connect into, or the client app to connect into the trade workstation from Interactive Brokers. This is your kind of gateway into the ecosystem or gateway of the Interactive Brokers for all your executions and data and all that. So let me just show you where I'm referring to. There's a configuration. Make sure you've got under there's an API settings. Make sure you click on these two guys, enable DDE and enable ActiveX and socket clients. Okay. So make sure you click on those guys. This is the application that we're going to start working with, and this PDF I just showed you actually is a very good, an amazing description of how to work with it, how to build it. So essentially, this will become the high frequency trading platform interface, or GUI. What I'm probably going to do is either remove or just disable these buttons. I'll obviously have an automated way to auto connect and disconnect, and a lot more intelligence. But these are the three consoles that I'm really interested in for output: TWS server response, errors and messages, and all the historical and market data. So there's three different consoles within one interface, which is kind of nice. Also, because I'm local, I don't need to specify the IP address, the port, that's standard for the TWS, and the client ID. Just so people know, the TWS allows up to 8 connections into itself. And what I'm looking at maybe architecting is the ability to have, let's say, this maybe client be specific for Forex, another client for Forex, another one for futures, or just try to divide it up maybe by asset or whatnot, have multiple clients connecting into my TWS. Alright, so that's that. So that's pretty well the only real tricky part. But let me take you into the Visual Studio. In the Visual Studio, there are your it's going to stop my debugging. Okay, so essentially what you're asked to do in that PDF I just showed you is to create a sample socket client. You do that. You also need the other projects of shared and test socket client and socket client, and essentially those are from your download of your GTS. Let me just pull that up. So it's all here, shared socket client. These are all at the same level, and you do that because, again, this is all explained in the PDF. It's all right here. No, it's in there somewhere. Yeah, here's all the instructions for your Visual Studio. But this is specific to 2008. You'll see that this is 2010. It's pretty well the same, except where you locate your include directories and all that kind of stuff. So essentially what you need to do is come under Properties here, and then under C++, General. Look under Additional Include Directories. Again, that's all explained in the PDF. You'll see that they're on the same level of those two projects I just showed you, shared and socket client. And the other thing is the code generation. Make sure for both modes of debug and release that you do set it to multi-thread. You'll get unresolved externals and all kinds of stuff. So those are the two things that you should be aware of. Also, make sure you click on your 64-bit as well, and then you should be able to build it. You'll get a lot of warnings. I'm not worried about that yet, but the app does run from within the Visual Studio, as you can see. I'm just going to create another client ID. So that's typical. You're going to get accept a incoming connection attempt, and I believe you can automate that. So you'll get here the connected message. No idea what that is. Now, another thing that you need to understand is, one thing I love about Interactive Brokers, you can do all this without registering into Interactive Brokers, meaning you don't have to fund an account. They don't even have to know you, which is really good. So all this data is not real. It's just simulated. But what do you care, right? It's free. And it's really good to play with as you build out your platform. I'm gonna, obviously, once I get a little more serious on the strategy side, I will be at some point opening and funding a Interactive Brokers account. So let's proceed. Okay, so essentially in this application now I am connected. There's a few things that this PDF will explain. How, you know, it's really good. It gives you just a brief overview of all the different functionality that you can get within the IB API, as well as some ways to call it. But obviously you're doing this through a form-based app, meaning you know, everything's all done through a button, but you can't automate it with you know, using this code base for reference. So let me just maybe get the historical data on all the QQQs. Okay, hopefully this will work. Guess not, maybe, I don't know. It does work, I know that. Real-time bars on the QQQ. Oh no, maybe I had to put in SPY. Let's just check that out. Maybe, oh, there's some kind of error message. Let me just try the yeah, so there you go. There's some data coming back, and then you can request market depth. Remember, this is all simulated, so you can get your market depth all simulated of your market depth, and I believe there's an example of how to get level 2 as well. So everything seems to be working just nicely. It didn't take me too long to figure all this out without considering, you know, here I'm going to rant on about Linux and all the open source stuff, which I do love. But as you can see, the productivity is quite substantial with this combination of Windows, Visual C++, and what I haven't shown yet, but I've shown in other videos, is definitely MATLAB. So from here on out, I might do some freebies, but a lot of the development from here on in is going to take place in this new app. It's going to be very similar to this for the Quant Labs high frequency trading platform, meaning I think we've pretty well taken it to as far as we can for all the free stuff. Everything else from this point on will be proprietary, because obviously they are strategies from within MATLAB, as well as the code that I will use through either a DLL through the MATLAB compiler or the MATLAB coder, which will be just pure code-generated C++. So I will be dropping it into this interface. On top of that, I haven't yet delved that deep into the CUDA, the GPU, but it's something that looks really cool, and I'm still chasing that down as well. But that's actually very advanced stuff. Definitely not for the faint of heart, but it's really good. I just want to show you some other discoveries that I've seen. There's something called Tesla Compute Cluster. Okay. Now I put up some links on this already, and essentially there are two versions of this. Now everyone probably asks, what's the difference between a Tesla board and you know, the cheaper GeForce boards. The big difference is clustering capability. So what you can essentially do is you can chain these Tesla boards together in one CPU. Currently, my basic account, sorry, my basic GPU card takes up one slot in where the graphics card is. So these cards right here will enable you to have multiple Tesla cards in one CPU. You can't do that. I don't think you could do that with lower end commodity hardware. You are getting into a specialized type of server for obviously, you know, clustering and fairly intense graphical processing units, and these cards can go up to all the way up to $1,000. So it's a totally different type of specialty. It's not a cheap way to go, but for productivity, it is definitely the way to go. Now, one thing I want to highlight here, again, bringing it back to Windows versus Linux. If you're fairly unknown to Linux with CUDA, CUDA and Linux do work in tangent. The problem with, I'm finding Linux, it's a real bitch to administer, and I'm not a big fan of it as much as I am obviously with Windows, being as productive I have been over the last week getting stuff done. I'm probably gonna, if things go well, I'll definitely be looking at this Tesla computing cluster on Windows, and it's specifically this is a special driver that's again only available to the TCC with Tesla, this one right here, and there's special versions for Windows HPC. If you're not familiar with Windows HPC, you may want to check it out. Windows HPC. It's a special version of Windows specifically designed for basically high processing and obviously high performance computing. So if things go well, this is definitely something I'll be looking at. And obviously there's an Azure solution as well. So maybe I might go that route, I don't know. But it's definitely not a cheap option. So that's the way things are looking. As I said, we've got our little Visual C++ test client with a TWS socket client working. Data connecting into the TWS, like as it here. You do get all the source codes you want, and you know, it's pretty good. I'm feeling good about the direction, and I'll be breaking down the code. I'll be looking at the POSIX version of this client app and see how that goes in terms of building it for maybe with that one. But we'll see, and I'll take it from there. Hopefully this will help you out, and we'll talk to you later.